Hello guys, welcome to my YouTube channel. In this video series, I'm going to take a look at Introduction to Algorithms book. My main focus is on the exercises available in the book, but also I will take a look at the examples and also algorithms in the book. I begin from chapter 2, section 2.1. The first algorithm in the book is insertion sort. Suppose that an array A is given to you. The elements are 5, 2, 4, 6, 1, and 3. And it's asked you in increasing order the elements in array A. We use an index counter J and it's begin from 2. So we are taking look at the second element in the array A. So we say that the second element is 2. Is it more than the left element or not? If it is smaller, so we should change the positions of them. So 2 goes to the place of 5 and 5 come to the place of the second element. So also we increase the J in the book by a black. It shows the position of the index J. So we take a look at the left hand side of the 4. The 4 is bigger than 5 or not. If it's smaller, so we change the position. So we change the position and J, we increment the J. J is now 4. 6 is more than 5, so it's not necessary to change the positions, so it's already sorted. Always notice that the left hand side of the J is sorted. For example, in here we have just 5. 5, it's one element, so it's sorted. Here J3, the left hand side is 2 and 5, it's sorted. Here it's sorted. Here J is the last element, J6. The left hand side is sorted. Now we just need to insert the elements 3 in this left hand side. So because of this, it's called insertion sort. Here, let's continue. J is 4, it's sorted. So we increment J from 4 to the 6. Now J is in here. So we should insert 1 to the left hand side. We take a look at the element in the left. It should go to the left hand side. Again, we take a look. 1 is less than 5, so they should exchange the position. Also, we continue until 1 and 2. So also in here, we should exchange them. So 1 goes in here and the other elements are going, it's just shifting the other elements to the right. Now, here J is 5, we increment J to the 6. And here 3. It should come to the position of the third element, which is 4. And the other ones should be shifted 1 to the right. It's just one element each time. Here, again, we increment J. J goes to the 7. When J becomes more than the number of elements in A, which is 6, so we should stop the algorithm. Let's take a look at the algorithm. Insertion sort. The input of the algorithm is A, the array A, and we should order them in an increasing manner. So we write a for loop. The for loop on index J begins from 2 to the last element. We begin from 2 because the first element is already sorted. So it begins from 2 to the length of the A. A is our array and length is its attribute. Here, the length of the A is 6 in this special example. Also, these black boxes, we call them the key element, AJ. Here, when we begin, J is 2, so AJ is 2, so the key element is 2. This is the explanation. Insert AJ to the left hand side. We make I in the left hand side of the J, which is in here, it's 1. In here, it's index 5. So while I is positive and AI, the left hand side, is more than the key element. Here, for example, key is always 1. Key is not changing in this lines. And we compare here, for example, the I is 4 and the J and I plus 1 is 5. If it is 6 is more than the K, so we should exchange them. And more left hand side. And we'll continue this until I is positive and AI is more than key. This is AND, so whenever it finds a place in here, it finds a place, so we don't need to continue until I is 0. We just continue until AI, the i's element in here, i's will decrease one by one, and it will come to here, so the AI will become less than key, so we'll exit from this while loop. When we exit from this while loop, AI plus 1 will become the key element. We will continue this n minus 1 time, which n is the length of the A. Here, look, it's 6 times we continue the for loop. The while loop can continue, here it's 1 time. Here, we do not enter the while loop. And here, it goes 1, 2, 3, 4 times. It can go up to n minus 1 times, but it can go also less. And at the end, the result, array A, is sorted in increment order. Notice that the insertion sort is in place algorithm. In place means that we do not need another array, which is more than a constant number, to copy our elements to there. So we just need the array A or a small memory. In here, we don't need another memory. So the insertion sort is in place. Also, another word is key element. The key element in here is the one which is inserting in each iteration of the algorithm. You can better understand the algorithm with this picture. These are the left hand side, 2, 4, 5, and 10 are on the left hand side, and we want to insert the element 4. We want to insert element to the left hand side. We take a look and we see that 7 is less than 10, so it should go to the left. Again, 7 is more than 5, so we don't need, so this is the place of the 7, and it should be placed here. The key element is this 7. Next, I will take a look at the exercises of this section.